Okay, perfect. All right. So the last time we actually have had an introduction, complexity theory, and we analyzed and we have analyzed the as a very simple sum method. So let's actually have a look at it again. So just in case you guys have forgotten. So if we have a simple sum which takes an array of a size n, and we set the sum to 0, then we have a for loop which says that I equals to 0 and I is less than n, I plus plus. And then we have s equals to s plus a of I, and close this, and then we just simply return the thing, right? So return s, and we close the whole thing, okay? So as we have mentioned last time, we were analyzing this in terms of how much time it will take to execute this, and let me pick something like this one. So we said that this will take 1 time unit, so this will run only once. So when we call this method or this function, it will be called only once. And then when we try to analyze this, we said, okay, so this will be called once, right? Because the assignment in the for loop is happening only 1 time. This will happen n plus 1 time, because there is going to be additional execution where we need to actually make the check, where the check will fail, right? And this will in fact will run for n times, right? And then from the perspective of this for loop, this guy will run actually for n times. The sum of these two guys, like for all the elements in here, so how, like this line of code, how long it will take for it to execute, we said that, so it's going to be like 2n plus 2. Oh, man. And this is why I really would like to use the whiteboard for MS Teams, because of these glitchiness. 2n plus 2. Okay? So that's that. And this one obviously will run 1 time. The polynomial order of this, the polynomial order of this guy, of this method is, when we actually sum all these guys up, we will end up with about like what, 3n plus 4 or something like that. We can actually approximate this by saying, okay, I'm gonna actually like ignore this, right? So actually not ignore this, but for example, like ignore this and maybe ignore that bit, and we can just simply say like it's gonna be n, so this will run n times. We can approximate this to an n time, but it doesn't matter at the end, right? Because when we say what is the polynomial order of this function, so if you have f of n equals to that, the polynomial order is the highest power in the actual like polynomial no, not equation, but it's expression, I would say. So it's going to be actually order of n. It's not big O, it's called order. So this is the polynomial order, okay? And this is what we have covered the last time. And I just simply like revise this again just to refresh your memory, because I'm going to start like hitting on that idea. right? We're gonna actually start exploring, like dig further and analyze for more algorithms, okay? So let's actually have something more interesting. So the sum method or the sum function is actually relatively easy. So I'm actually going to erase all of this. So maybe I'll just, yeah. Because this was actually has been mentioned in the previous material, and it's already, you have already not only the recording, but you have already the blackboard. So I'm just going to erase all this. And right now we're going to write something fresh. So assuming that you have, and right now we're going to look at, from now on, let's say we're going to look at the time complexity. I will not look at the space complexity right now. Maybe I will mention it here and there, every now and then, but for fun, but let's talk about time complexity more, which concerns us at least here. So if I have an add, so if I'm trying to make an add, adding two matrices, for example, okay, so if I'm trying to add A, matrix A, and matrix B, I have to supply the size of the matrix, assuming that the matrix is a square matrix, okay? So square matrix is just a matrix where the number of columns equals to the number of rows, A, B, C, D, F, G, H, I, right? So this is called a square matrix. This is a non-square matrix, right? So if you have, let's say, two elements, which is going to be A, B, C, C, D, E, F, G, H, right? This is non-square matrix. Today it's super glitchy than ever. I don't know why. Okay. So that's why my handwriting is kind of wiggly for some reason. So for I equals to 0, and I is less than n, I plus plus, and then we open braces, and then we have another for loop, because we are summing a square matrix. J equals to 0, J is less than n, J plus plus, and then we open a bracket or braces, and then we try to sum this. So C of I, J, because we have a matrix C somewhere out there, it doesn't matter right now. It's going to equal, well, I mean, where we're going to store the result, A of I and J plus B of I and J, right? Very simple, nothing super fancy or anything. Of course, you return C somewhere below, but right now it's none of our concerns. Let's simplify things and keep things lean. So the question comes here is like, how do you analyze this? Can somebody give me a guess based on the previous example? Can somebody give me a guess what would be the time complexity of this function?
N squared.
Okay, can you please tell me why?
Well, because we have two for loops, and in the previous example we saw that one for loop has a order of n, so two for loops are gonna have an order of n squared.
Exactly. So, but I mean, this is actually, I mean, this is correct, but I would love even more accurate answer. So, what I wanted to say is, there are some parts. We're gonna see later on. Hopefully, the time will be enough for me to cover this bit. But sometimes, like, there are certain patterns which you're gonna see, which you can't call it like the student way of hacking the exam. For example, whenever you see a nested for loop, it's an n squared, right? But assuming that you lost your way around and you totally forgot that, for example, a nested for loop is an n squared. How are you going to actually reason about this? How you can get out or unstuck yourself while you are on the test, if you are in a test, for example. How you can analyze an algorithm correctly. And what you're going to do is, for example, say, okay, I will actually pick, for example, this color. And I'll say, all right, so this guy will run for approximately, so I'm going to approximate it right now. Let me actually make this line a little bit longer because this guy's long. And we can say that this line will run for n plus 1, for example. Okay, you can even say it's n for now. Okay, so this will run n times approximately. And as a consequence, whatever is actually underneath it will run. So if this is, let's say, okay, let me put this even better. So let me put this plus 1 for now, just for now. This will run, this line of code will run actually n times, and this will run n times. Okay? And we are done with this line. Okay? Now let me pick up another one. So right now we need to analyze this line of code. So how many times this line of code will execute? Well, this will execute actually n plus 1 times. So into, which is multiplication. So multiply by n plus 1. So this guy, let me just write it like this. So this guy will run n plus 1 times. And this guy will run as well into n. Okay? So if we would like to sum this, this will end up actually with what? Like, so you end up with this one is n. Oh boy. The glitch is strong with this one. N squared. Oh wow. Sorry. N squared plus n. And this is going to be n. And this is going to be n squared. So we are ending up with 3n squared plus 2n. Or actually, no. Actually, it's 2n squared. It's 2n squared. Sorry about that. So 2n squared. And the thing is glitching like hell, honestly. Sorry about that. It's really MS Teams, when it hooks up to record, it's just screwing up with my stuff. Okay. Oh, sorry, plus 1. Before I forget that thing. Oh. Maybe even plus 2. Or, no, it's actually plus 1. Okay. So this is basically how you calculate the complexity of it. So if this is a function, so this is an f of n, what is going to be the order of this function? Can somebody tell me? Oh, n squared. So you actually had, like, oh yeah, I actually asked this question before, sorry. So because of the highest order, so we can say that the order of this function is O of n squared. Okay? So this is how you could reason about it. Like, if you were stuck in the exam, you figure your way out. Can somebody tell me what is going to be the, just for fun, the space complexity of this? How much memory it will take? Like, what is the order of the polynomial function of the space complexity?
So we would have probably one word for the A matrix, a second word for the B matrix, one word for the N.
One word for A matrix, he said.
Yeah.
No, A matrix is an array, man. It's a two-dimensional array. Two-dimensional? Yeah, it's two-dimensional array.
So then 2 words?
No, actually, this is gonna be actually n squared, n square, because you have like 2 dimensions. So you have like 2 dimensions of integers. So the order of the space complexity of this guy is actually Sn equals to order of n squared. Again, you are using two-dimensional array. All right. And also the c is actually, so this c guy is also n squared. So yeah. Okay. Now, let's say that I'm going to throw at you a curveball here, and then I'm just going to give you factorial calculation. So what happens if you do something like recursions? Factorial. And then factorial, I give an n, which for a number, and then we say if n is less than or equals to 1, then you return 1. And then we have else. Whoa. Return n times factorial. Man, what the heck? Factorial n minus 1. So what would be the... can somebody tell me what would be actually the time complexity for this?
Well, the base case should be just 1.
Okay.
But it's gonna run every time the function is called.
So
I guess n, because the...
Okay, so true. Actually, it's n. It's gonna run. This guy will run for n times. Actually, for every recursions are actually quite difficult. Well, not quite, but relatively difficult to figure out, because some of the recursions you cannot, it's actually quite difficult to untangle to make it like to make it as a for loop. Some of them are trivial, like the factorial, for example, because the factorial can be turned into a for loop, so we know that this can be an actual n. But if it is not, then you're going to have to analyze it further. If it was a different kind of, if it was a different kind of recursion, like we have much more complicated branching algorithms or something like that. But I just wanted to leave it here. This one actually was mentioned in the book, Algorithm Analysis in C, the one which also I gave you. I gave you the title, and I always reference the pages from there. So I just thought that it would be good to mention this one, because sometimes you might meet such a thing. So let's go ahead and have one more example. Let's say that we're going to do some array operation. Doesn't matter what it is, but let's say it's going to be just a simple operation. So I'm just going to make I'm just going to call this function array operation. Which takes an array and assigns n. And then we're going to have a for loop. Int I equals to 0. I is less than n. I plus plus. Whoa. And then we're going to say a of I equals to 0. And then we're going to have another one. So for loop. So for, actually, I don't need to write int, but apparently it's a force of habit. So I'm just going to change it right here. So if I equals to 0 and I is less than n, I plus plus, then we have another for loop. J equals to 0. J is less than n. J plus plus. And then we're going to open a bracket, and then we're going to say a of I plus equals a of I plus I plus j. Then we're gonna close this, and close this, I think. So there we go. So just to be clear here, so this is here, this is there, and this is there. Okay, I just showed you the alignment, so in case my handwriting is awful, you can notice. Now, can somebody give me a guess? What would be the time complexity of this?
Maybe n to the power of 3.
What is the reasoning?
Well, actually, no, because the first for loop doesn't nest the other two.
So at the end, what is going to be the time complexity?
N squared.
Okay. Anybody else? Just to see like what others think, or is it too early in the morning for you guys?
Well, the most logical looks like n squared.
Well, actually, it's actually true, but the idea here is like I'm trying to get more interaction because I'm trying to see how you guys think about it. You know, the funny thing in the exams, what I've seen people do is that they randomly assign things whenever they see a function, and I had to ask them what's going to be the time complexity of it. All of a sudden, they just simply like, you know, they just simply assign, like they say, for example, one of the exams, this was given, this precisely this, and people just, you know, put it n to the power of 3, and others were actually put it O of n for some crazy reason, I don't know why. They just simply tried to hack probably the exam, but they hacked it in the wrong way. So that's why I usually ask people like to see how they think about things, so I can actually like correct the thinking. So when you see something similar on the test, you can actually like get yourself out. And obviously, when real life, when you actually get into these kind of things, you need to make sure that you don't shoot yourself in the foot. Okay, so for those who don't know how to, don't know how to hack this. So this is running for an n time, right? And this is it. So this is like this is just the end of this, and then the compiler will go, and then we'll just the compiler or the runtime, whatever, they will run actually into this n times, and this will run for n time, and this will run for n time. Now, because we have a nested for loop here, this guy is already run there, so this guy has finished, right? And then we say, okay, this loop we already have analyzed. However, this loop is going to be executing another n times, right? So from the perspective of this guy, this and this will run n times. And then from the perspective of this guy, it will run this time and this time, right? So n and n. And at the end of the day, you have O of n squared, because this is n squared, and this is n squared, right? And this is n, and we are grabbing the highest order, highest polynomial order. So this is going to be O of n squared. Okay, sounds good.
Can I just ask one question?
Yes.
So is there a type of a rule that if you have a higher order function in lower lines of the code, is it gonna override the smaller or the less time complexity of order of? So basically, if you have order of n squared, is it gonna override the order of ON?
So are you saying that, for example, if you had, if I understand you right, so your question is like this. So if you have a function, let's write this in white because it's going to be a little bit more easier to see. So you are saying that, oh, come on, work with me. Function. Okay, let me just write it here. So if you have a function, and then you have, for example, a for loop, and then another nested for loop. So for da 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 da, then for another one, and then you have another for, right? And then you have just a normal statement here. This is going to be evaluating to O of n squared. And this is going to be evaluating to, no, sorry, not O of n squared. This is going to be evaluated to n squared, and this is going to be evaluated to n, right? And your question is, it should be O of n squared, right? Is this what you want to ask?
That's what I wanted to ask.
Yeah. So yeah, it actually will. It's not about who comes later, by the way, or who comes first. It's about you are actually evaluating the whole thing.
It just comes about the higher, who has the higher complexity.
Exactly. You are actually analyzing the whole function, just the whole thing, yeah. And the order, by the way, the order is the order of this function. It's not the order of any of these lines of code. It's like the order of the whole block. Okay. So now that's out of the way. Just raise this. Okay. So let's actually look at something. Look at something a little bit more, a bit easy, and then we actually like summarize what we have learned so far, and then dig deeper into something a little bit more interesting. Okay, so let's talk about, for example, let's give another example, which is going to be matrix multiplication. So multiply. Imagine that we have a multiplication function which does multiply two matrices. So you have a 4. I will not actually write int I anymore. I'll just simply write I equals to 0. Because in pseudocode, we don't care actually. And I is less than n. And I plus plus. And then we open braces, and then we have another for loop. And then we have j equals to 0. J is less than n. And j plus plus. And this is because we are working with square matrices, similar to what we do in graphics, for example, and maybe as well AI. Like this is the stuff is given to your GPU mostly, but if you execute it on the CPU, it will look actually like this, more or less. I mean, C I and j equals to 0. But we do not forget the other bracket, and then we're gonna have another for loop. So for k equals to 0, k is less than n. Wow. K plus plus. Then we have a C of I, j equals to C I. Man, it's like super glitchy. Plus A of I and K times B of K and J. Hopefully, Microsoft Teams will allow me to write finally. And this is going to be closing this bracket because this belongs to this, and then we close this bracket because this belongs to this. And then we close this bracket because this belongs to this one. Then we close this bracket because this one belongs to that one. Okay, so here is a very simple piece of code that just simply multiplies two matrices. For the hackers out there, if you are hacking an exam, order, what is the order of this function?
Is it the power of 3?
Exactly. So if you are hacking an exam, you see something like this, and you would like to blaze through it. There you go. You just simply like look at the for loops. You see three nested for loops, and you are actually good to go. So perfect. Let me see here. I just need to. Okay. Perfect. Now, for those who actually, I was actually trying to log into MS Teams from my other PC just to be sure that I don't miss questions if somebody has written any question, and they didn't voice it out. Okay, so for those who might, for example, forgot how to like the rule of it, so let's actually. Okay, let it be. So let's actually do the reasoning behind this real quick. So this will run n times, and from the perspective of this for loop, for heaven's sake, it just erased it right away. So there we go, n, and then we have another n, and then another n, and then another n, right? So let me actually extend even those lines further just to match, to be everything to be in line. So n, n, well, this will run n times, it doesn't matter right now, but n, okay? From the perspective of this for loop. Now, from the perspective of, now this is done, now we are done with this guy. Let's talk about this guy. So this guy will run n times, so into n, and eventually this will run as well into n. Okay. Oh man, there we go. Let me try to write this in a normal way as much as I can, as much as Teams allows me. And this will run as well n times from the perspective of this for loop, right? Now, let me pick up another color, so let's be blue. And let's analyze this one, okay? This one will run approximately into n, and this will run approximately as well into n, right? This is going to be, and this will equal at the end to n to the power of 3, n to the power of 3, and this is going to be n to the power of 2, and this is n, right? We can add these guys all up, but instead of just like trying to sum things up, you can just simply approximate this and say, okay, this is going to be the highest order. So the order of this function is going to be O of n cubed. Okay. So this is a very simple mechanism. I think you already have got the hang of it.
I'm sorry, can I just ask a question?
Yes.
On the exam, is it enough that we just write like order of n on the power of 3, or do we have to write?
No, it's
how we
enough.
got
It's
there?
enough. Yeah, it's enough that you actually say when the exam on the exams you're gonna get like a function, and then you say, and then I'll ask what is gonna be the order of this function. Right now you analyze it on your own, you figure out your way, and then at the end you just simply write n okay, this is going to be a log n, n log n, or O of n squared, or something like that. You don't need to write the reason behind it.
Okay, thank you.
Yeah, because I'm assuming that you really need to look into the code, so you cannot these things you cannot get it by memory. I mean, you cannot memorize the code, so you have to like look at the code, analyze it, and get it right. So excuse me. So at the end of the day, if we look at some patterns, right now you actually start to recognize interesting patterns, right? So if we are actually looking at patterns like these, so let's talk about some recognizable patterns for the hackers among you. Some, let me be consistent with all the documents, right? I usually write in high caps. Some recognizable patterns. Right? So at the end of the day, you get like a for loop of I equals to 0, and I is less than n, or more than n, it doesn't matter. And then you have I plus plus, right? And then some statement goes here, a simple statement that it doesn't have nested function calls or anything like that. So this is just a simple statement, right? We immediately know that this is actually running for n times, right? As large as n will go, this will just simply run for that n times, okay? Given like this line of code at least will run for n times, okay? Given that the statement is simple, so we know that this is going to be n. And it's going to be actually the same thing if you are actually having a for loop. So for I equals to, for example, to n, and I is larger than 0, I minus minus, it's exactly the same thing, given that you have a very simple statement. So this is actually, let me actually write this down so people do not forget. So given that this is a simple statement, okay, this is important. So maybe again, simple statement or statements, it doesn't matter, right? The main thing, you don't have a complicated function call in here. Statements, okay? It's going to be also running for n times. Oh boy. N. Okay? Now, if I actually give you something like this, for I equals to 1 and I is less than n, I plus equals to 2, right? And you have a very simple statement, okay? What is going to be the order of this function? Don't give me the order.
It's the same, man.
Sorry?
It's the same, it's n.
Okay, but can you give me the reason why it is n?
Well, we have.
Well,
go ahead, young lady. Let's say it's the ladies first.
Well, we don't have any nested for loops, so every for loop is just going to run for n times, and that's going to be the highest order, so it's just going to be n.
Okay. Fine, but okay, but do you know what is actually the can you please tell me how many times this will run? Because this cannot run for
1.
No, this cannot be running actually for n minus 1.
That's the point. N divided by 2.
Exactly. This will run for n divided by 2 because you are skipping every other element, practically speaking. But she was right, actually, that actually is going to be the order of n, and everybody else who said it's order of n, because this is the highest order, right? So that's why at the end of the day, this is going to be O of n. Okay. Now this was actually a trick one. I mean, this simple trick. Yeah.
I just have a quick question. say we have 3 for loops, and we have n, m, and k. So they all run for n, m, and k times. For example, if n is the highest number, we have specific numbers. So it's, let's say, 150. So it's going to be 150.
No, wait, I don't get you. So for I equals to 0 and I is less than 150?
Yeah, let's say specific number.
And then I plus plus. Okay, and then another for loop nested?
No, not nested for loops, just 3 for loops.
Oh, 3 for loops. And then you're gonna have j equals to what? J less than 50?
Yeah, sure.
It's gonna be like j plus plus. And then you're gonna have a for loop for, let's say, ibjk equals to 0 and j or k is less than what?
70.
70 is gonna be k plus plus, right?
Mm-hmm.
So what do you want to say?
So
What
here we just did the n or k, which is actually so it's just a number, so it's going to be 150 if I understood correctly.
Actually, no, it's gonna be like if you actually like hard coding like the numbers like this is gonna be actually running 150 plus 50 plus 70. You have to add them all together, right?
Right, yeah. But if it's the same number, then it's just going to be n times. So it's all of these are 150, it's just going to be n, which is 100.
Exactly, it's gonna be that n because all of them are the same. Okay. So that's a very important point, which is thank you for the question. So yeah, this is a very, very valid question. Like, what happens if you have several numbers, right? So at the end of the day, if you know exactly what are these, then at the end of the day, like what, 270? So this will be actually 270 times, which actually at the end of the day is just approximately O of n, because each one of them is just running for the exact amount of elements in there. And this is actually almost a constant time. All right, so let me actually remove this. Thanks for the question, and let's go ahead and dig deeper. So we said this was one of the patterns, and then we're gonna have like, and then you figured out another pattern, which is a for loop, a nested for loop. So we said that the for I equals to 0. I'm just writing all the patterns right here just for you to have as a reference. And I is less than n for the hackers among you, apparently, or at least. Another for loop, j equals to 0 and j is less than n, then j plus plus, hopefully. And then you're going to have a very simple statement going on here. Nothing nested or, I mean, no nested functions or anything. We know that this is running for n plus 1 times, and this is going to be like n plus 1 times, and times n plus 1 times, right? Which we approximated it into an n at the end of the day. And this is going to be running n times n, the simple statement, right? So this is the simple statement running n times n. And at the end of the day, we know that it's actually going to be running for, right, n squared times, okay? Now, if you actually have something like something that might confuse you a bit, do not also get confused, because if I give you actually I equals to 0 and I is less than n and then I plus plus, and then you figure it out one day and say, okay, I'm going to actually give you j larger than n, or yeah, j larger than n, or actually j equals to n, sorry, and j is larger than 0. And then we're going to have j minus minus, okay? And your simple statement goes here. This at the end of the day is still n squared, okay? Because this will run n times and this will run exactly n times as well. It's just except one of them is just running, one of them is running forward and the other is running backwards. And that's pretty much it, okay? So right now we have these simple patterns. But let's actually get some more interesting examples. So these are the patterns which you can do. If you would like to hack an exam, there you go. Just, you know, like if you see these patterns without any crazy things in between, they're perfect. But what if you got something like this? So we got 4 I equals to 0 and I is less than n, I plus plus, and then we open braces, and then we have another one for j equals to 0, j is less than I, we have j plus plus. Okay? And then you have a very simple statement here. So your code goes here. So code goes here, which is super simple statements, nothing crazy or nested. Can somebody tell me what would be the time complexity of this guy?
N?
Nope.
N squared.
N squared.
No, but okay, do not, you see, like she gave an n and you gave n squared, but I mean, what is the point? Why?
Well, the first
Well,
Because
the first for loop is gonna run for n times.
Okay.
And
oh, actually,
from its perspective, it's gonna run n times, and then the nested for loop is gonna run also n times.
It cannot
but-
run n times, man.
it's just I think.
No. Okay, okay. I mean, I understand that. Here's the thing. Like, when you get stuck like this. So right now we are like trying to guess things. This is, let's say, for now, for the time being, we can actually comfortably say that this is unhackable. Okay, you try to hack it right now using the patterns which you saw. Right? I'm not saying that some of your answers are incorrect. I'm just saying that right now you actually face this in the exam, let's say, or face this in an interview, or face this in real life, and you're trying to debug a program why it is running for so long, and you're trying to analyze the complexity of this. This cannot be hacked that way, at least for the time being. So what you usually do in this case is just simply walk through it. Right, just do it by hand. You will see it. So let's actually draw a table. Like right now, this is like programming 1. I think you have seen this already when you were in first year. So let's plot this. So let's say we have, we're gonna actually look at, let me see, I'll try actually to use different colors here just to make things a little bit more lively. So J, I, and J, and then we're gonna have, oh, for heaven's sake. And then we'll look at the code. Okay? So let's draw a table. Okay? And I will actually pick up yellow, fine. Okay, so at the beginning, at the very beginning, I is going to equal to 0, right? And then we will go down. J is going to equal to 0. Is J is less than I? Nope. So here is going to be no execution. No exec. I will call it that way. So this guy will not execute, right? For the first loop. Okay, so this loop is done. We're gonna get out of it, right? So let me draw a line here. I'll have to pick up this guy again. Now I will increment, right? So this is gonna be 1, and we will get inside, J will be 0. Is J is less than I? True. So because I is right now 1, J is 0, J is less than I, so we actually have an execution. So we have exec, we execute this line, okay? Now j will increment while I is still 1. So I is still 1, j will increment. 1 is not less than 1, so we're going to have no exec again. So no execution. Okay? And end of the second for loop into that nested for loop, and then we get back here again, right? Let's do one more. So if I is actually incrementing, so I is going to be 2, we'll get in here. Right now, j is going to be equal to 0 because we are executing this again, right? So j is going to be 0. J is less than I because j is 0 and I is 2. Then we're going to have an execution. And obviously, j will increment in the loop again. So we incremented by 1. We're going to have execution. And then still I equals to 2 because we are still stuck here, right? And then we're going to have j equals to 2. And 2 is not larger than 2. So we are actually having no execution, right? And then we just draw another line. Let me actually continue this a little bit further, just to drive the point across. So I is going to equal to 3, right? Because we are incrementing again here. So j is going to equal to 0 because we are running this again. And we're going to have an execution. 3, 1, execution, right? We are incrementing j again, according to the loop. And then 3 for the I, and then 2, then we have execution. And then another 3, and j becomes 3, and then we have no execution, right? Because we have because 3 cannot be larger or less than 3, right? And then you carry on, right? So I'm not actually going to go for 4 because you already see the pattern here. So this will go on. All right. Now, if you look carefully, let's actually see this. So if you look carefully, like in the first loop, no execution. So while I is 0, right? So it's going to be like 0 execution. And then when I becomes 1, we have a single execution. Then when I becomes 2, it becomes 2 executions. Then 3 executions, right? So when you're actually starting to sum up how many times like this is being executed, so this is 1 plus 2 plus 3, right?
Like
plus 4. So basically speaking, what you do is just simply say, okay, this is going to be like this function, this f of n is equal to 1 plus 2 plus 3 plus 4 plus n, right? Now, the sum in math, the sum of the natural numbers, because you are actually summing this, the sum of the natural numbers is actually going to equal to n times n plus 1 divided by 2. This is actually the sum of the natural numbers because you are practically speaking running this once, then 2, then 3, then 4, and you are just adding up this execution. Like the first loop you are running it 0 times, then the next loop you are running it 1, then the next loop you are running it twice, and the next loop you are running it 3 times. So every loop you are just keeping adding up the number of executions you are adding. So that's why we are adding up the numbers. So the first loop you are making 1 execution, the second loop you are making 2 executions, the third loop you are making 3 executions, and so on and so forth, right? So so at the end of the day, when we sum up all these executions, it gives you this. And at the end of the day, this will equal to n squared plus n divided by 2. What is the order of this function?
n squared.
N squared. So when you actually get an answer, you have to get it for the right reasons. Do not get the correct answers for the wrong reasons, because it can cheat you, or actually can fail you at the end. Okay? So whoever said it's n squared, it is actually true, but you have to know why you are doing it, why this happened. All right? Let me throw you an even more curved ball, let's say. So I'm actually running right now without a break, so I will actually like release you earlier, or finish a bit earlier. And actually, like, I'm not gonna be there for long either. So because I'm actually gonna have to stop where I have stopped with the other people, so we don't, so all of us are gonna be in sync. Okay, so one more example, and let me draw a line right here. Does this make any sense, by the way?
Yes, it does. But I don't think I would have ever guessed why the answer was n squared.
Well, okay, it's fine. I mean, all of us are learning here, so it's just totally fine. But the main thing is that right now we understand why this is happening, right? And how you can, if you actually forget, how you unstuck yourself, right? So that's the important thing. Like, master the basics. Like, okay, I forgot how to do this, or I forgot what is the meaning of this. Let's walk through it, right? So if you walk it with a pen and a paper, and figure this out step by step, then you can get to the same conclusion. That's the most important thing. Perfect. Let's actually give you another example. So if you have something similar to this, so p equals to 0, then you're going to have a for loop. For I equals to 1, and p is less than or equals to n, I plus plus. And then we have p equals to p plus I. For the hackers out there, can you guess this one?
Well, probably just open.
Yeah, the order is just n.
The order is just n. The reasoning? Any reasoning? If you are trying to, I mean, if you are, hang on. Let me just write this a little bit closer to this. P
I'm
equals
sorry, just what does I equal to?
1. Is it clear now?
Oh yeah, okay, then it's just the normal thing.
Okay. Just to be clear here, my handwriting is really affected by the MS Teams when it's. By the way, when I'm not recording my screen or not sharing my screen, the tablet writing is super smooth and everything is just fine. But when MS Teams is like trying to capture my screen and stream it to you guys, everything just goes glitchy and crazy. So that's why sometimes there are certain things that just simply go off. So sorry about that. But carry on. So the answer was for the hackers.
It's just n.
It's just n. Okay, so stop hacking. Just to be clear here, stop hacking. Because this cannot be an n. But anyway, let's walk through this, shall we? So let's walk through. Let's see how this will actually pan out. So I will actually draw a table again. So I'll actually have an I here. I'm gonna have P, and I'm gonna talk about my code, right? How many times this code will run. So I'm actually gonna draw a line right there, right there. Oh man, please just hang on with me. There we go. There we go. Maybe even I'm just trying to get it. Oh, actually, I have a ruler here somewhere. At least I remember. There we go. 90, thank you. And then just do it this way and do it this way. And thank you very much. Now, let's analyze this. So, yeah, I'm going to use yellow again. So when I equals to 1, right, and P equals to 0, okay, P is going to be 0 plus 1, right? So let me just write it a little bit better. 0 plus 1. Are we good? People?
Yeah.
Yes.
Okay. Now, moving on. When I is going to be 2, P was 1, because P has been set to 1 already previously, right? P became 1 here. So it's going to be 0 plus 1 plus 2. I mean, I'm just copying this guy here. Okay? I'm just saying that this is what was previously, and we just added 2 to it. That's what I'm saying, nothing more. Okay? Drawing a line right there. I'm just trying to split them up so to make it easier to read. And then when I is actually 3, P is already what? 3, right? Which will make P already 0 plus 1 plus 2 plus 3. And then let's do one more. And, oh boy. And I will be incrementing to 4. And P by then will be 6, because 1 plus 2 plus 0 plus 1 plus 2 plus 3 equals to 6, right? So this equals to 6, this equals to 3, this equals to 1, right? So just to be clear here, how much is P, right? So this will be, and by the end of the day, this is going to be like 0 plus 1 plus 2. Oh, for heaven's sake, come on. Okay, so sorry about that. 0 plus 1 plus 2 plus 3, come on, plus 4, which is going to equal to 10, right? And then we'll actually just keep repeating, right? So this will keep actually repeating. But for how much? This is right now will repeat for actually k times. It's not going to repeat for n times. It's going to be repeating for k times. And I'm saying for k times because p is less than n here. You are not, if you use p as an indexer, if I take p right now and try to index it into a certain array, it will not actually work. It will not go n times as large as the array, for example. It will go in an interesting stepping, the step is going to be quite different, how it's actually stepping through the array. So it's actually going to be skipping a lot of elements, right? So, and this will be actually adding up to, so 1 plus 2 plus 3 plus 4, and then plus, how many times is going to be plus 4k times? Because this is actually running k times, right? At the end of the day. So all of this is going to be running for k times, not for n times, but k times. So let me just put this here. So at the end of the day, what is going to be the order of this function? So this is going to be the good question here. So when you think about it, so we said that sometime before, so P, when you look at it, the P as in the code execution, it is actually still, again, the sum of the natural numbers, right? So 0 plus 2 plus 0 plus 1 plus 2 plus 3 plus 4 and so on and so forth is actually the sum of the natural numbers which we have covered upstairs here, right? So at the end...
So it's going to be like mathematical induction again. So just k squared is going to be in the end?
Not k, well, okay, k squared, but we're gonna actually have to define it in terms of function of n. So let me show you the reasoning. So let's actually, I mean, you are close, but let's go a little bit more precise. So assuming, so since p is actually equals to, so p is in fact the sum of the natural numbers, right? So it's going to be k equals to k, because this is running k times, right? So it's going to equal to k times k plus 1 divided by 2, right? If I actually take this guy, substitute it instead of here, okay? So because actually we have a stopping condition, so since p, let's actually like write it down. Let me write it down again like this in a word so you can actually remember it when you read it on your own while you're studying. Since p according to code execution equals to sum of all natural numbers. Okay, we can say that p equals to, and we are running for k times, so p equal to k times k plus 1 divided by 2. And then assuming that the end condition or stopping condition, you call it that way, I mean, either way is okay. End condition is when p is in fact larger than n, right? So when p is larger than n, it will immediately fail, right? So as long as p is less than or equal to n, it will be fine. Once p exceeds n, it will actually fail. So we can say that assuming that the stopping condition is actually p when p is larger than n, what I'm going to do here is actually I'm going to grab this guy, substitute it instead of p, right? So I'm just going to grab this definition. I'm going to say, okay, at the end of the day, k equals to k plus 1 equal k times k plus 1 divided by 2 is larger than n, right? Which actually at the end of the day, this is going to look like this, k squared plus k divided by 2, right? Larger than n, which we can right now, let's say if this is going to be the order, if we are trying to grab the order of this function, or this bit here, this can be approximated to k squared larger than n, right? At the end of the day, this is going to be k larger than square root of n, right? So when we take out this, we're going to have to square root this. This is right now like elementary school math or high school math, I cannot remember anymore, primary school math. And what is the polynomial order of this? O square root of n. Does this make any sense?
Yes, it does.
Are you guys okay with the reasoning?
Yeah, it's good.
Any questions for anybody else?
I have one question, but it's not regarding the last function we explained.
You have one question regarding what exactly?
Let's say we have a function and it has a for loop, and in that for loop we have a function that defines something else. How would we calculate that one?
So if you have, for example, something like this, a for loop with whatever stuff in there, and then you have another function, right? Which says do operations on X and Y, right?
Mm-hmm.
Then you cannot actually analyze this. You have to analyze this function first.
And what if that function has a nested for loop?
If that function has a nested for loop, this is going to be O of n squared already. And this is O of n, and this is going to be O of n cubed. Because right now it is as if you took the nested for loop and you injected it into here.
Mm-hmm.
So at the end of the day, it's going to be O of n cubed.
Okay, thank you.
Okay. Okay, any further questions, you guys? I mean, it's very important that this actually should be clear to you. This, right? How you reason about what is happening. Let me give you another one, okay? So let's take another one, and I'm gonna actually stop after this. So this is gonna be the last example, and then I will let you go. So far, we have covered almost a lot of patterns in here. Okay, so let's say you have a for loop of I equals to 1, I is less than n, but this time I times equals 2. If you would like to make it easier to read, I equals to I times 2. And then you have a simple statement. And now, can somebody give me a complexity for this? If you don't know, hey, you see, here's the thing. If you don't know, perfect. Let's not hack it, and let's walk through it, right? So can somebody like take just 2 minutes just to walk through it? Everybody, I asked you just to go ahead, just take the 2 minutes and walk through it. And let's see.
I think it's log n.
Why?
Because we go times 2, so we iterate faster through n times.
So at the end of the day, it's a log n, you say?
Yeah, I think so.
Okay. Why it is not a square root of n, then? I'm just asking. I'm not saying that you're wrong or right. I'm just asking. I mean, what your answer is right, but I just wonder, how do you think about this?
Square root.
No, I'm just saying why it is not this one. I mean, why it is really specifically log n. Is this a guesstimate, or first of all, is it a guesstimate, or there's a mathematical induction, you just reach to it?
It's a mathematical induction, I think, but I don't know how to explain that. So
then you hacked it, huh?
Kinda.
Yeah, it's a hack. Stop hacking, you guys. Stop hacking your way through. It's a bad idea. I mean, it's a good idea, but
I'm just a competitor, so
yeah,
I know.
no, do not hack it that way. I mean, you might shoot yourself in the foot one day, so that's why I'm just saying. But I mean, you are right at the end. But let's talk about the reasoning, shall we? So when we guesstimate or when we hack it, let's hack it for get the answers for the good reason. So that's a very important thing. So So let's talk about the analysis of it. So let's analyze it. So we are actually caring about I at this time, right? So at the beginning, I is going to equal to 1, which is just fine. And then the next time is going to be I times 1 times 2, which is going to be equal to 2. And then 2 times 2, right, which is going to be 2 squared, right, when you think about it. And then it's going to be 2 squared times 2, which is going to be 2 cubed. And then you are actually like running for 2, you're going to be running. So let me actually write this. I will write this into words actually, so you can so you guys can remember this. So since I equals to I times 2, we cannot, the code does not execute for n times. Okay, the code does not execute for n times. And since we don't know how long it will execute, we know for sure, it will execute for 2 to the power of k times, right? It is not n times, it's just k times, because this is this power is actually keeping incrementing, right? And it doesn't match n anyway. So so how are we gonna actually, so assuming that the stopping condition, this stopping condition, like the code will just stop executing the for loop when I is larger than or equals to n. So let's say it's larger than n, and I is equal to 2 to the power of k, right? This is how we actually got to it, isn't it? So we can say that 2 to the power of k is larger than n, meaning that if we actually try to simplify this relationship, according again to the high school math or to the primary school math, k is going to actually equal to log base 2 n. Okay, because you would like to know how much is that k. At the end of the day, is going to be O of log n. And by the way, we are always working with base 2. It is, this is like our logarithmic functions is always base 2, is assumed to be base 2. So that's why in books we don't write, I mean not we, but in books you will not see people writing log base 2n, they will just simply say log n. Okay? Now, if you are trying to hack your exam, right, and you saw a for loop like this, if you multiply by 2 or divide by 2, you are always in that logarithmic function, right? That's pretty much it. Does this make any sense?
Yes, it does.
Okay. All right. Any questions for me? Guys, are you still alive? No? Okay. Let me, all right, so let me stop the recording right here. I think I'm actually done for today. And next time we're going to explore more interesting things. And probably talk about asymptotic notations afterwards, so we can actually finish up this part of the syllabus. I'll stop recording.
So we need to